All right, good morning, everyone. Apologies for a little bit hiccup with clicker. Welcome to sunny San Francisco, Bay Area, California, the capital of cybersecurity. I'm kidding, it's Oakland, the capital of cybersecurity, because that's where Teleport is headquartered. Good to see you all here. I hope you will be entertained. I hope you will learn something new today. I hope you will talk to each other, because there are lots and lots of brains in this room, and I'm pretty sure we have experts on everything. But I'm here in front of you to talk about securing our computing infrastructure against identity attacks. And we probably should start by examining what is infrastructure and what a typical identity attack looks like. The reason infrastructure is being attacked is because hackers want something that infrastructure has, and that's usually data. And we usually do computations happening on the data, and in the process, there are kind of two types of actors that are involved. On one hand, you have humans who constantly telling machines what to do, and on the other hand, there are machines that are actually trying to do what humans told them to do. So therefore, if you want to attack this process of computing, if you're looking after stealing someone's data, you really have a choice as a hacker. Are you going to go after humans, or you are going after machines? So how would machines normally get hacked? I think this is, we all see it in the movies. This is where hackers find some kind of exploit, and they exploit that 0-day, and they try to upload malicious code into some remote computing system, and that's really how that attack happens. So those attacks are often called malware attacks. But when a human is attacked, we call this attack identity attacks. Example of those, like phishing, for example, is a very common type of an identity attack. This is where an attacker is trying to trick human into making a mistake. So that's really the choice. If you are hacking into some kind of organization, you need to decide, like, are you gonna go after humans or machines? Now, which one of these is more popular? What do you think? Those who think that malware attacks are more common, raise your hands. Oh, we have an educated crowd here. So yeah, that's right. Identity attacks are much more popular. By the way, it hasn't always been this way. And frankly, if you were to ask yourself what governs this distribution, identity versus malware, it's basically economics. So if you're like a crime syndicate and all you do is hacking all day, you probably want to invest more money, resources into launching attacks that are more profitable with higher ROI. And identity now is easier. And that's thanks to you, thanks to all of us. Because we, over time, we learned how to develop robust and secure software. So launching malware attacks is now just much, much more expensive. So how do we prevent identity attacks then? Let's examine what a typical identity attack looks like. And most of them follow this very simple pattern. It's called exploit human error and then pivot. What does it mean? Exploiting human error means that every attack begins with a human doing something stupid. We are extremely unreliable moist robots, so we're predictably making mistakes all the time. These mistakes might include things like clicking on the wrong attachment, or clicking on the wrong link, or sharing our private key with a friend who then leaves the company, or leaving your laptop on subway or in a cab, or misconfiguring something, putting wrong value in a configuration file. So all of these things are human errors. And an identity attack is about exploiting that error just to get a foothold into your organization. Maybe by exploiting a human mistake, an attacker will just get into a single laptop. But then pivot happens. Pivoting means using that laptop as a springboard. An attacker is trying to get into adjacent system within your organization. Maybe from your laptop, they might try to get like AWS credentials and get into your AWS account and so on and so forth. So human error followed by a pivot. Therefore, if you were to prevent an identity attack, all you have to do, it's really simple. First, you prevent humans from making mistakes in your organization. And second, you make pivoting hard or impossible for an attacker. Well, easier said than done. So how do you actually do this? How do you stop humans from making errors? And how to prevent pivots? Let's start with pivots, simply because it's easier. We as an industry collectively several years ago, in fact many years ago, it's not a new idea at all. I believe Google's paper was published in 2004 or 2005. So you stop pivots with what's commonly called zero trust. It's not a buzzword. It has actually a pretty decent definition that everyone can find, but for your all's convenience, I compressed it down to a very simple thing. Zero trust basically means that you should not trust your network. In fact, network shouldn't even be considered, like ideally, when you're thinking about cybersecurity. Zero trust simply means that all computing resources that your infrastructure consists of, they should always assume that attacker is already on the network, which means that all connections need to be authenticated and all connections need to be encrypted. So it's a fairly simple concept. Again, it's kind of costly to implement, particularly when you're dealing with a legacy system. But for new systems, it's pretty simple. Like, here's your iPhone. Like when Apple is operating a giant cloud of billions of these devices, that's a zero trust device. It doesn't really trust the network because it doesn't even care which network it's on. So if you can design your infrastructure to work this way, you will prevent pivots. So now we need to move forward to preventing human error. This one is much harder. Why? Because it's not a technology problem. As I said, humans will reliably, constantly, will keep doing stupid stuff. And as you could probably imagine, if you have twice as many people in your organization, the probability of one of them doing something stupid today, this very second, is twice as much or twice as big. So, what are the reasons that prevent us from preventing humans from making mistakes? Well, just look at the slide. I'm not going to read every single reason, but as we evolve and as complexity of computing generally is increasing, as organizations grow, as the world that we live in is becoming more and more regulated, preventing humans from making a mistake gets harder and harder. But the second reason why humans now making more mistakes than ever, and this is actually the reason I believed that why identity attacks are on the rise right now, is complexity. We all know that your infrastructure you're responsible for managing and securing today is much more complex than it was 5 years ago, 10 years ago, 20 years ago. I like using this example a lot, but when Facebook got started, it turned into a multi-billion-dollar company. It was a LAMP application. All you needed back then to start a giant business was the LAMP stack. Linux, Apache, PHP, MySQL. You learn how to secure those 4 things, you're good to go. Now, you can go meet a startup here in San Francisco with 50 engineers maybe, and you ask them what your stack looks like, and they will go layer after layer after layer of technologies, containers and microservices and Kubernetes and Grafana and CI/CD and Jenkins, and the list will go on and on. They will use 5 different databases for 5 different data types, and a big data as well, because why not? So every single layer in that stack listens on a network socket, has its own login, has its own permissions, authorizations, has its own configuration file with its own config syntax, has its own log and audit and compliance requirements. Most teams simply don't have the expertise to secure everything they have. Consider a very simple rule. The developer must access this production database under these conditions. How would you even implement this rule today in a modern infrastructure? Because the laptop of this developer has an identity, developer themselves, there is identity of a database, identity of a server. All these identities are stored in different places. There is VPN, there is Okta, there is privileged access management solution. So identity is fragmented, policy is fragmented, there is complexity everywhere. That is why humans are making more mistakes than ever. Complexity kills. So what do? How do we prevent humans from making errors in order to stop identity attacks? Well, you cannot. The best you can hope for is to reduce complexity as much as you can and then shrink the surface area of credentials. Because credentials are exposing humans to human errors. Credentials are making human errors exploitable by attackers. Because at the end of the day, what attackers want when they exploit a mistake is to get some kind of credentials. I get into your laptop, from your laptop I get your AWS credentials, I get your SSH credentials, I get the API key for Stripe or something. So have fewer credentials and reduce complexity. Now, how do we do it? Advice number one, and this is not specific to Teleport, but I do hope that this advice will be generic enough. Have one source of identity for everything. What I mean by this is that there should be a single system, single source of truth for identity of devices, cell phones, laptops, servers. All hardware identities need to be in one place. Then you need to have identity of people in the same place. Then you need to have identity of workloads, identity of software you're building, also be in that same place. Why is it so important? Why it reduces complexity so much? Because if you have identities of everything and everyone in one place, then you can enforce zero trust easily. Then you can have a single source of policy easily. That reduces complexity dramatically. And the second big piece of advice is to adopt ephemeral credentials. So I'm talking about things like certificates that are issued based on physical properties of a device or a human. Those of you who are Teleport users, you know how we do it. So you touch a fingerprint reader on your laptop, which means the private key stored TPM on the laptop is, which is registered with a source of identity, which is Teleport. So you get issued based on your fingerprint a temporary certificate, which is good for a very short period of time. And that certificate is tied to this particular laptop and to you as the owner of a finger. And then it expires. So in this system, there is no static credentials that an attacker can steal and run away with, even if you commit a mistake. In other words, and sometimes I actually do have this question that I ask like potential customers or maybe just people in general, it's like, what is the probability of you getting hacked today? Well, the probability, even though we don't know what that is directly linked to how many secrets you have sprinkled across your entire organization. So if you have fewer secrets, preferably 0 or 1, then it means that your infrastructure becomes resilient to bad human behavior, resilient to mistakes. And the third powerful tool to reduce the impact of human error is just-in-time access. The idea here is fairly simple. Like during steady state when nothing is happening, no one actually needs access. Why do you want to touch your infrastructure? Let it run, let it go and run software. But if there is something to do, maybe run a deployment, or maybe check some kind of monitoring anomaly, the access needs to be granted just in time for this particular individual to go complete the task and then revoked, which means that you're shrinking your attack's surface area on the time dimension. Which means that every other laptop in the company is like pointless to hack into because that laptop never has access to anything. Because again, access is granted only for a short period of time. And then obviously observability is important. Having a single place where you could see what is going on allows you as well to, having that visibility allows you to instantly kill a compromised identity, for example. It could be identity of a laptop. So laptop got stolen. Let's go and see if that laptop has any active connections and kill them all and prevent that laptop from being used. Or if an engineer quits your organization, you can also quickly see if there are any connections or sessions that are created by that identity. So if we were to bring this all together, what is the vision then for like a full security stack that prevents identity attacks, or at least significantly reduces probability of them? This is how it looks like. At Teleport, this is what we're trying to build. Not every single layer is 100% implemented, but we're working towards it. You see at the bottom, you have identity, a single source of identity for everyone and everything. That's absolutely necessary to prevent that siloing of security concerns in many different places. On top of that, we layer zero trust networking. We call it zero trust plus because not traditional, because in some business circles, when people hear zero trust, they just assume that it's encrypted connection from human to a web application. But we point out that, hey, that web application is just iceberg, it's just tip of an iceberg. It has microservices running. It has some caches and queues and databases and Kubernetes infrastructure underneath. Like all of these connections, when they talk to each other, they also need to be zero trust. Fully authenticated, fully encrypted all the way down. This is what we call it Zero Trust Plus. Then on top of this, you have ephemeral privileges. Ephemeral credentials and privileges. So this is what we call the policy management layer. And then finally, at the very top, you could have identity governance that, again, needs to work for humans and machines. And it helps you with things like compliance. And then you could have a dialogue with your access control systems, like who has access to what. Show me what resources this particular person has access to if this happens. This is what we all want, because at the end of the day, a modern access control implemented this way makes you feel that your entire infrastructure is like one giant computer. It has a simple control that you can dial in who has or does not have access to that machine. So what are the benefits of this dramatic simplification? Actually, benefit number one that is immediately felt is simplicity and essentially productivity. When you as an engineer interacting with your company infrastructure and you're not faced with the need to manage multiple credentials, VPNs, then yeah, it does feel like you're having a dialogue with a single machine. It's like giving instructions to the matrix. But security obviously is why we're doing it. Because by simplifying your access control stack, getting rid of credentials, getting rid of silos, and having single source of truth for everything, it's just one thing to manage as opposed to hundreds. And makes it easier as well to deal with these increasing regulations that we're all seeing across basically most of the Western world right now. We are preparing an infrastructure access report. It's a survey that we've done with industry practitioners that you will be able to download on our website. And I wanted to take some takeaways from that report and share them with you today. So we asked organizations what was the average cost that they had to pay due to security incidents throughout the year. So the analyzed average cost due to hacking, essentially. And the top third of all these respondents, we call them leaders. So they did much better than the bottom. And the bottom third, we're going to call them novices here. So you see that there is a dramatic difference in how much these organizations got affected by identity attacks. So leaders, they on average only had to lose $600,000. And novices basically had to pay 10 times as much. How did these two groups differ? So we asked them, are you using this? And here's the results. So leaders were 67% more likely to use passwordless authentication. So they really took the advice of getting rid of credentials seriously. Also, they employed cryptographic identity for resources. It basically means certificates. So using certificates to implement zero trust connectivity between different components of the infrastructure. Same thing for users. Leaders were 55% more likely to adopt this. And as you see, by the way, using an identity manager, essentially SSO, IDP, the difference was only 19%, which basically means that it's a technology that's now widely adopted and doesn't make much difference, which means you need to move forward. So as you can see, this advice on how to deal with identity attacks is real, because there are already organizations who, again, this is not Teleport specific, that was much wider survey that we've done. Implementing these principles allows you to significantly reduce your exposure to identity attacks. So, TLDR, simplify, and get rid of secrets. That was my presentation on how to deal with identity attacks in 2024. And next up, I want to introduce Sasha Klizhentas, our CTO, who's going to be talking about closing the access loop. Sasha.